this one easy, this one easy, this one the two calls to this function. And if you go back to the inLab, I think this is the inLab, right? This is inLab. Okay, and the two functions calls that timer one set interrupt handler. It's, if you go back to here, so on the top you can see that first it calls your ISR, right? And if you do control click, you can get into here. It's passing that ISR into this function. So this one is getting called, and another one, this timer one set interrupt handler, is being called in the initialization. So when timer one is getting initialized, it calls this function, but it's immediately getting overwritten by the another one, because the real interrupt handler becomes your ISR, right? So my ISR something, okay? And also ask about the second call user programs ISR will be what ISR will your program use to service the timer one interrupt. So this is pretty obvious, because what ISR is eventually being used is actually your ISR over here, right? So which is this function, right? And another one, so the daughter function of this interrupt manager, so you come back to here, so find out this function. So the one with the underscore here will be the real interrupt handler, and you can find out, because this one is defined by the hotwire. It's going to directly get into here when interrupt happens, and then it runs into this ISR function, timer ISR function. If you click, control click, you can see it's actually handling what? It's actually taking that timer one interrupt handler, okay, into this timer one ISR function. So this one, so what is this one though? This one is, if you just remember this variable name, it's actually timer one interrupt handler, right? So it was set by here, right? It's setting this guy as an interrupt handler. If you come back to here, you can see this my ISR, timer one ISR, will be passed into this function and being assigned to this variable. So that's why eventually this one is being used in this pre-designed, right, by the digital engineers who designed that microchip to handle that interrupt routine, service routine. Okay, so that's the structure, basic structure of all these interrupt functions. So this is a pretty good question to let you understand what's really going on inside all the functions. So the daughter function, you already saw that, right? What does the daughter function do to this guy? So the daughter function is, if you come back to here, right? So the daughter function, when you do one, you can see this is the daughter function of this guy. So what this function does, you just get into it and you see it's clearing that flag, okay? That's why in the main C file, in the timer writing function, before and after that, see here, right? So it's not actually clearing that flag by itself, because whenever it gets into this, it's gonna clearing that flag by itself by this one. That's why you see that in here it's getting cleared, right? And another one, where's the variable being loaded? This is pretty simple, because you can see that's in the initialization in here, right? So here is being initialized. Here is a variable. And what is the first and last thing that happens in the function? So if you come back, the first and last thing in that my timer ISR is it has this test pin set on and set O as a testing mechanism for your interrupt code. And the flag, okay, the flag. So the flag we are talking about over here is basically the two flags. One is the increment the node, another one is a play node. So you have to play node first. So whenever you press the increment the node, during the interrupt, it will play the node and add one to the node index and play the next one for the next time. So it's just another extra layer of control for the playing for the timer within the interrupt service routine, right? So what behavior would you expect if you remove this one? So if you remove this one, assign the false to this guy, what's gonna happen? So you press the play node, it's gonna start playing, right? Toggling this pin to play the node, and the next time it enters the interrupt routine, it will keep incrementing that node and without a break. So this will not become false at all. So it's always true, always increasing. So which is not going to give you a correct notes and song. Right? Include the screenshots of the waveform of the scope. Use the sum drive to capture it. So this is the testing, because in here, that's the lab work. If you haven't done that yet, please go ahead and do it in the lab. And it's just probing that testing high and low, because in here, whenever it gets in the interrupt, it gets the high, and then whenever it's done, it set it to low. Okay, so you zoom in, change the timing scale, you should be able to see the pulse. Okay, so if you zoom in from the X scale and probe at 10% and 90% of the full amplitude, you should be able to measure the delta X over here, which will give you the time duration, which is the rising time, and then you use the voltage difference between the two, the delta Y, divided by, which is here, delta Y divided by delta X to get the slew rate. So it measures how fast the voltage rises, right? And use the rise time. Okay, it's the same problem. And compare the time spent inside when it's not playing a note. So when it's not playing a note, you basically just comment out this one. So see how long it takes. Okay, and this timer writer function is largely responsible for the time. So you can measure it by having that testing high and testing low above it and below it, so you can see how long it takes. And when this is true, and this gets initialized to half the period play, and play with this, determine the initial count. So the initial count becomes 0, because every time it gets into the interrupt routine, the timer 1 is getting cleared, right? So it's already overflowed. So it's always 0 in there at the very beginning. Okay. So using the body rate, so the body rate is 9600 bits per second. If you count the number of characters over here for this guy, do something, right? It's a testing for printing out that. So that one takes the body rate. The body rate is 9600 bits per second, and you totally have so it's 8 bits per byte, and you have 13 bytes, right? So you can get a total number of bits, and that number divided by 9600, you are getting how long it takes to finish the printing, right? So if you get that time duration to print out all these characters, and you will be able to measure, compare that with the interrupts time durations. So that serves for another question in the list here. So use T to measure the actual time it takes to print out. So that's something we already talked about. And you got a theoretical time, you got a measured time, you compare them, and press B. It enters here, right? Enters here. And the thing is, you are not disabling that timer or interrupt, it's always getting to here every 4 milliseconds. So if we draw it, it's basically like you got 4, for example, this is 4 milliseconds, okay, 4 milli. So it's going to trigger this all the time. However, that's the interrupt. Every 4.096 milliseconds, it triggers the interrupt, right? It comes into it. And so if we press B, it's not doing anything but the printing. So it's going to start printing over here, right? And then it lasts for 1, 2, 3. So like 11 milliseconds, it will be here, right? But by the time it finishes, it's still within that interrupt, and it's performing like a stack because it hasn't finished the second interrupt code yet. So it's gonna keep running the interrupts without stopping it. So that's what's gonna happen. If you get another example, for example, the printing a very short string, like still assume this is the 4 interrupts, right? For example, the printing is shorter than 4 milliseconds, okay? It's gonna finish over here. So after it's done, it's gonna quit. It's gonna quit this interrupt and won't wait until the timer's up. It's gonna quit, and whenever it quits, what's gonna happen is it will wait for another 4 milliseconds to get back into it again. Okay. However, during that time, you will be able to do a lot of things like detecting the press of the buttons and other things. But if the printing itself or the function inside the interrupt is longer than the interrupt itself, it's going to cause issues like this.